Hi internet people, I'm David Smolinski. I invented a heat exchanger. I call it the inhale-exhale heat exchanger, and the purpose is this heat exchanger would go on a cold weather mask. Not like this one, but you can imagine like just a kind of a balaclava, and it would take the air that someone exhales and use it to heat the air that they inhale. And there are valves that make it so that the person is breathing in fresh air. I described the invention in a different video. But I'm going to talk about the experiment I did, the measurements I got that give an idea of how effective this device is, and helps people determine whether it's worth pursuing. I think it's worth pursuing. Now, some people say this is really bulky. This is just a prototype. I wanted to make it as efficient as possible, and I wanted to use easy materials. So the real thing might sacrifice a little bit of efficiency to shrink it down, or better materials would make it smaller. Plus the mask part would be different. So I think in the real thing, I think the inhale chamber could be shrunken quite a bit. So like half of the chamber size is the inhale chamber, and if that's cut in half, let's say, then you shrink the chamber size by 25%. I think it could be shrunken more than that though. And then if you shrink the exhale chamber, you probably reduce efficiency a bit, but it still might be good enough. So this invention is described in a previous video. This video is just about the experiment I did. So this is screwed on, and in the real thing, it's not going to be screwed on. It will have a much easier enclosure. This is an example of an easier enclosure, just like a plastic latch. Someone should be able to just pop this on and off easily, so they could clean out condensation with a stick or something. So for my test, I left this outside overnight under my father's canoe so that it would become the same temperature as the outside. And then the next day I Next day I measured the temperature before wearing this. It was, this is all in Fahrenheit. It's what I'm used to. But I guess I should be doing this in Celsius. But the temperature before wearing it was, well, I have two different temperature probes, and one read 21 degrees, another 24 degrees. The one that read 21 degrees was inside the inner chamber of the, right before the inhale valve, so right in there. And the one that read 24 degrees was right here. So yeah, the location of the two probes was, I used thermocouple probes. And this probe thermometer was cheap. So if you can see, the probes take a reading right at the tip, and this probe stuck into this space, right before the inhale valve. So here's the cover, and it just went like that. And there was another probe that is stuck right in here. So it was maybe an inch in front of my mouth. So I called the readings for the first probe, the one that was in right before the inhale valve. I called those readings T1, and the probe I called those readings T2, and the probe that was right before the right in front of my mouth, maybe an inch, called those readings T1. So I wore this for 12 minutes, and I just walked around, paced around, and I took readings every 3 minutes. So my first reading was T1 was 82 degrees, T2 71, and my second reading at 6 minutes was 68 degrees for T1, 75 for T2. Third reading was 85 degrees for T1, 78 for T2, and the final fourth reading at 12 minutes was 85 degrees for T1, 78 for T2. And then experiment, I did a couple other measurements. I know when I take my body temperature, when I'm healthy, it's always a constant temperature, definitely within a degree. So it's always 98.6, plus or minus a little. And when I put a probe underneath my tongue and waited, I got a reading of 91.4 degrees. So I also checked an outdoor thermometer after the experiment, and I got 19 degrees. So this shows that this probe thermometer is a little bit inaccurate, but it's accurate enough to show that there's a significant heat savings here. I think this invention is worth pursuing. Of course, I can always get more accurate probes, or I could set something up with the Adafruit trinket, which is it's a $5 Arduino. But I believe that I could be pretty confident that I saved at least 50 degrees. I might have saved as much as 70 degrees. So in order to pursue this more, I don't have a lot of money. I don't have a lot of business experience, and I would like partners to we could come up with some kind of a contract, or I don't know, maybe it would be nice to sell the rights to this invention to a company that would be really good at making it, or I haven't decided, but this information is useful for convincing other people that it's worth pursuing further. I'm sure there could be a lot of improvements, and I think the final product would be really useful. It would allow people to do construction work when it's really, really cold. If they have trouble breathing in that really, really cold air. It would save people a lot of efficiency. It would save people a lot of money. It could be useful for the military, maybe. Maybe their soldiers would perform better if they weren't freezing their lungs. So I think this could save people a lot of money, it's just very useful to save energy. So please comment, like, subscribe. Talk to me if you want to make any kind of a deal. I'll see you later. Thank you.